Hi, I'm Neil from Genio Roasters, and welcome to our Tech Talk Session 2. And in the studio today we have Donovan McLagan.
Thanks for having me, Neil.
Yeah, welcome. So Donovan is the owner of Cobol Roastery based out in Port Elizabeth, and he's also a certified AST trainer for roasting and for the new course that SCA is offering.
Yes, C-Tech Technicians course for brewing equipment and espresso machines.
Yeah, and Donovan actually consulted on the curriculum.
Yeah, writing of some
SCA.
of the curriculum, yeah.
Yeah, that's beautiful. And so Donovan is also our local South African national cupping champion for 2012, 2015, 2016, 2018, and he placed 5th in the world back in 2012, which is phenomenal. So well done on that.
Thank you.
And we're very fortunate to have you in the shop today. Cool. So the Tech Talk Session 2 is specifically centered around gas. So we sent out a call on Facebook for our customers, the roasting industry, whoever it may be, to send in questions regarding gas. How does it work? What are you struggling with? Because there's a lot of misnomers out in the industry about what to do and how to fix it and so on. So we're going to run through the questions, and then we're going to our test bench where we took all the innards from a Genio, put it out on a board so that we can see each and every component working on its own, and also do a little troubleshooting. And thank you very much for our technical team that put that together. We're very happy with it. And then Donovan is going to share some of his experiences with being a consultant out in the field. Yeah. And the typical questions that he gets from his customers. And then second to last is we have a little clip from Nicodemus Nabakwe from Seven Oaks Trading, who's a qualified Q grader, and he's going to give us some practical tips on how to get the best results out of your coffee, and also specifically pertaining to a shot in the dark. So that's going to be quite nice. And then lastly is we have a lucky draw for the people who sent in questions to this particular Tech Talk. And they're going to win 3 hampers of Morten Munchen's Coffee Mind gear that we have over here. Morten is from Copenhagen, and we have a beautiful coffee palette and some books about roasting and sensory training, and I think that's a really nice prize to get.
Can I get a question in quickly so I can win?
No, you cannot. Too late.
Too late, too late.
Okay, so we're going to dive right in.
What would be the best way to get my gas flow higher if my gas bottles are installed far from my roaster? I've already installed extra gas bottles as well as installed a bigger gas pipe. Is there anything else that I can try? Well, if you haven't already tried, you can have a 2-stage regulator, a high flow at your bottles installed, and then a low flow at your machine itself, and making sure with your installer that all the flow rates in your installation are correct. Over and above that, I don't think there's much you can do.
Yeah, we have a 6-bottle bank in the factory, so 3 48 kilo cylinders per bank with a switchover manifold, running PEX piping, which is a 1/2-inch diameter, all the way through to our 6 assembly bays, and each of the 6 assembly bays has a low pressure regulator, 10 kilograms per hour, and we have no issue with flow over here. And it's probably a good 50-meter length of PEX pipe all the way from the bottles to the test benches. So it can be done. You need to make sure that you have ample pressure at your bottles, going to a high pressure regulator, and then stepping down to a low pressure regulator right before the roasters.
Perfect. Will a 48 kilogram gas cylinder be enough to roast regularly on a 15 kilogram roaster? Is there a tool that I can use to measure the amount left in my gas bottles so that I don't have to run out of gas? Well, I wish there was one to give us a reliable reading of what's going on. But what you could do, if your installation is close to your roaster, we would suggest a changeover switch, having 2 bottles installed. So as your gas pressure starts to decrease on your gauge that you'll see on your roaster, you can quickly run outside and change it over. If your installation is like Neil's, which is 40 meters away, we suggest putting an automatic changeover switch, which is inexpensive and worth the investment.
Yeah, that's about maybe 800, maybe 1,000 Rand for an auto switchover. So it detects if the pressure is starting to drop on your one bank, and then automatically just clicks over to the other bank. And for that kind of money, you know, you can easily put 2,000 Rand worth in coffee into your 15 kilo at a time. So having a switch over, having an auto switch over is really worth the investment. And then knowing how much gas is left over, guys, pour hot water over the bottle to see where the line of compressed gas is down below. You get all sorts of things. Whatever you do, please don't invert your bottle to get the last bit of juice out, because we're not looking for the juice, we're looking for the gas.
Yes, absolutely. What is the best gas level or charge temperature? Well, this is a really common question, and I don't know why, but over the years I've heard the figure of 180 degrees charge temperature for any given batch size or any given size of roaster. I don't know where it comes from, I wish I did, but that is not necessarily the case. So some of the things to consider is your drums, your batch size of your roaster, what you're going to put in, is a very good thing to start with. And then obviously, do you have a double-walled drum? Do you have a single-walled drum? Understanding all the other components that go into making a difference when it comes to this question, Neil.
And I mean, you regularly go up to 230, 240 as a charge temperature on your roaster. Yeah. So the old misnomer of 180 degrees is an old school style. Nowadays with double wall drums, you can really ramp it up. And it depends on whether you have hard beans, soft beans, your processing method, and what kind of roast time you want out of it. So it's a very open-ended question at the end of the day.
Give us a call, we can help you.
And that's why people like Donovan are in the field, is to answer these kind of questions in a matter of consulting. And we're going to cover that in detail later on in the chat.
During the roasting process, if you need to improve your heat transfer, would you increase your charge temperature or your gas fluctuation accordingly, or would you lower your drum speed? Again, it fits into the previous question a bit. Just one thing to always consider, you never change more than one variable at a time, because if you do two, you won't be able to understand which change is giving you the most meaningful impact on your roast. And so always stick to one. So changing your drum speed is going to make a difference, changing your airflow is going to make a difference, and obviously changing your amount of gas or heat that you're using is going to make a difference for sure in this kind of scenario.
I'd always start with gas pressure first, because it probably has the biggest influence. But you need to understand how heat is transferred in the first place to your beans. Absolutely. So you need to understand what the impact of drum speed is. And the easy way of finding that out is to do test batches. So roast one with a high charge temperature, roast another with a lower charge temperature. Keep all of your other variables exactly the same on a Genio using the auto system, just changing the prime temperature. And play around and see what the impact is on your profile, and cup your coffee, of course, that's the important bit. And then secondly, change your drum speed and see what impact that has on your roast profile. Is it faster? Is it slower? Are you stalling the roast? Are you over roasting? Temperatures just shooting through the roof at the end of the day. So play around and cup your coffee.
That being said, Session 1 is a really good resource for you guys to look at. Neil and Tia cover everything in there when it comes to all the aspects that we just touched on right now. Is it common to see fluctuations in environmental and bean temperature when I connect a new gas bottle? It's not common, but I have seen it myself in a couple of situations. One being when I have changed manufacturers of gas bottles or gas themselves. I see that happening. And then the change of seasons, winter to summer, depending on how great that change is, you'll see a possible fluctuation in pressure at your gauge. So
I would agree that it's not a common thing to happen, but when it does, so we usually get calls in the beginning of winter or the beginning of summer for my gas flame color just suddenly changed. But that can happen throughout the course of the year, because the ratio of butane to propane is not a set ratio for LPG. So it depends on whoever's mixing it, what they're actually putting into the bottles. Some bottles can be old, some bottles can be new. There could be debris or rust or something down in the bottle. So yeah, it can happen, but it's not the most common thing.
How does the burner position under my drum affect heat transfer through the roast? Luckily for us as roasters, we hope and pray that our manufacturers have put our burner's in the position to give us optimal heat transfer into our drum. And so moving that around will set off a chain reaction for everything else that we use to transfer heat through our roasters. So if you move your burner, for instance, your amount of gas you're using for a charge will change. The way that the air is heated up in the roaster will change that coefficient, so you'll have to change that. And then I'll probably have to change your drum speed as well. So learning to understand how your energy flows through your roaster is very important. So I wouldn't suggest changing the burner position on the bottom of your roaster. But if you do, just know you're going to have to reset all your profiles.
Yeah. You know, we didn't just happen to put the burner where it is. It took many years to find exactly the right position, and all of our machines are standardized to that particular position. So you have to get used to what the machine gives you. The way that it reacts, it's like buying a new car and trying out the new clutch for the first time. It is what it is. You can't go and change that. So you need to learn how to drive with that particular car or with that roaster. So yes, in a Genio you can actually move the position of the drum. There are specific slots in the burner mechanism so that you can move it. I certainly wouldn't suggest it because if you give us a call and say that my beans are scorched suddenly and you forget that you actually moved the burner, that's going to throw us off the track quite wildly. So learn to use your roaster with the setup that it has, because you'll need to relearn it in any case if you change the variable like that.
If you really want to do it, I would suggest that you consult your manufacturer before doing so, like getting hold of Neil and the team, and they'll give you some suggestions and see if it's a viable option for you.
Yeah, but you also probably need a reason to want to change it.
Yeah.
So if you say that there's too much of this kind of energy or that kind of energy, or my beans are scorching at this point or that point. But with it being a standardized setup across our machines, I would almost certainly not point the finger to where the drum is positioned, and I'd look at your profiles. That will be the tell-all of exactly what's happening. Yeah. And before we start moving burner positions, I'd say just have a look at your profiles, and you'll probably see exactly why you're getting scorching or whatever the case may be in your settings and not in the setup of the roaster.
Again, session 1 is a good resource for you guys.
Very much.
Neil, should we head over to our test bench and see what we can get going there?
I think so. Let's go over to the test bench and play around with gas. Right, so welcome to our test bench. We have built this, or our support crew has built this, and I think it's quite a nice layout of exactly what happens in a coffee roaster. So we've got our gas bottle on the far side, going into a switch-over manifold to our high-pressure regulator, after which we have our shut-off valve. Now this little bit here signifies the distance between the coffee roaster and the supply, the gas supply, which might be outside or might be inside your shop. Then we go on to the low pressure regulator, and in our latest machines, the low pressure regulator is actually installed into the machine itself. So we do all of our setup and all of our calibration on the machine. All we need is a little bit higher pressure coming from your high pressure regulator, and we're good to go. Then we've got your gas valve and ignition system, the gas gauge, and your burner. And then we have a full control system linked up to this so that we can actually demo the various parts. Okay, so the first part that I'd like to speak about is the gas supply. So that's everything from here forward. So starting off with the gas bottle, we've got an LPG 19 kilogram cylinder here with a switch over manifold. So this is for my second gas bottle that I can connect up, and that's really what we suggest you do, is to have 2 bottles. Now in South Africa it is legal to have up to 1 19 kilogram cylinder in a building or per building. So unfortunately doing it inside of your building isn't possible with a switch-over manifold. For that, you would have to go outside. And that definitely varies from country to country and whatever your legislation requires. So check with your gas installer if you can possibly have a 19 or a 9 kilo cylinder inside. Otherwise, you'd have to take it outside, build it into a cage, and that's probably the safer and the better way to do it in any case. Now, for those customers of ours who have natural gas is typically supplied at 2.2 kPa or 22 millibars of pressure, which is lower than what we have here. So LPG Right now we're pushing 3.2 kPa, and we can take up to about 3.8 kPa or 38 millibars of pressure. So with LPG we have a bit more room to play with regards to pressure. With natural gas you can't really increase the pressure without spending money on a gas booster, which is quite expensive. But the advantage is that natural gas has quite a high calorific value per BTU, so we can get a lot of heat out of the 2.2 kPa that we are supplied with. So you can use any Genio or most coffee roasters, whatever brand they may be, on either natural gas or LPG. The one thing that you would have to change is the gas jet that sits inside here. So the jet disperses the gas into the oxygen, into the air, mixes it up, and then it goes into the burner blade here and gets ignited over here. So that's your combustion essentially. And you've got to make sure that you get the right gas jet. So for natural gas, we use a 1.0 millimeter, and for LPG, we use a 0.77 millimeter. Now that would also depend on your gas burner and what your manufacturer says. So just check with them whether you can make the switch over from LPG to natural gas if you want to. And you should be fine with 2.2 kPas of pressure on natural gas. We find that on all of our machines, while it seems like a lower pressure, because the burn rate is a little bit higher, it's not like you would have a slower roast or anything like that. The alternative would be to install a pressure booster, but that's a really expensive exercise. So try it at the 2.2 first before you invest in boosting the pressure first. See if you can hit your roast times. If you can't hit your roast times, speak to a manufacturer. Maybe you can make some setup changes to the machine before having to go the pressure booster route. Okay, so going from our LPG, we have our switch over manifold, and this is what makes it so simple. When one bottle runs empty, you simply flick the switch over to the other side. And what I would also suggest is spending the $800 or the $1,000 on a automatic switch over. So it's a spring-loaded system that you click to one end, and as soon as that bottle runs empty, it immediately clicks over to the other side. It really makes life a lot easier. Then going on to our high pressure regulator. So these can go up to about 3 bars of pressure. So you can have almost liquid gas running between this point and your low pressure regulator. I wouldn't suggest going that high. It's probably not necessary. As long as your pipe diameter is big enough and you don't have a huge distance between your bottles. But if you do, just boost your high pressure regulator a little bit. Make sure that there's enough flow. And when it comes up to here, that'll bring it down to the safe pressure that we can actually work with, which is anything from about 2.8 kPa, hopefully. And at the burner, we'll have that 2.5 that we're looking for in a Genio, which is our maximum pressure that we run. But in order to maintain the 2.5, we need to have enough pressure on the supply side. So if you can't reach the 2.5, there's 2 places to look. The first would be calibration of your gas valve, which will run through, and the second would be the supply side pressure. So when we look at troubleshooting our supply side of the roaster, firstly, if there isn't enough pressure, we'll pick it up in the gas gauge in that our maximum pressure simply cannot be reached. And that's how we know that there's definitely a problem supply side. Once your roaster is set up and calibrated, there's really no reason why you can't hit whatever target you always had, whether that be 2.5, 2.4, 2.3 kPas. If you're not getting it suddenly one day, it's almost certainly a supply side issue. Now what we do get, and Donovan and I quickly touched on that, is that some people want to squeeze out the last little bit of gas in the bottle and they take the bottle and invert it. But remember that we're not looking for the fluid, because the fluid is the compressed gas. We're actually looking for the decompressed gas. Okay, so if you do flip the bottle over, then that fluid gas is going to run up into your gas regulator and freeze it over, and then you won't be able to use it at all. So never ever invert your bottles. That last little bit needs to decompress. Now, when a gas decompresses, it's an endothermic reaction, and that's why when you spray deodorant on your body, it's always cold. So as the gas decompresses, it uses up energy, leaving the gas quite cold. And that's why our regulators can sometimes freeze over. So if you do touch your regulator and it's extremely cold or you see some condensation on it, then it could be that the flow rate through the gas regulator isn't enough and you need a higher flow gas regulator. So on a Genio, we usually use these, which is a 10 kilogram per hour 2.8 kPa regulator, but the nice thing is that we can remove this little cap and use an Allen key to screw in the diaphragm over here, and that gives us quite a bit more pressure, and you can fine-tune your maximum pressure using that gas regulator. Now these will be installed into your Genio by default, so from now on 2021 going forwards, all you need is a high pressure regulator and a shut-off valve inside your building. So ideally your gas installer will probably give you a shut-off valve at the high pressure regulator outside as well, but inside your building you definitely do need this so that you can shut off the gas at night when you go home, and then we simply connect onto the roaster, and all of this will be pre-calibrated by us in the factory. For those of you who have a previous model roaster, it won't have the gas regulator installed in the roaster, so this will have to be supplied by the customer, in which case we move this low pressure regulator just before the shut-off valve and use the shut-off valve as after the shut-off valve to connect to the coffee roaster itself. So in that case, you'll have your high pressure regulator, which is your first stage, going into your low pressure regulator, which is your second stage. Now with your gas regulators, we have had situations where the gas regulator can get blocked up because of debris somewhere in the gas bottles. Maybe it was dirty, maybe there's some rust inside, or whatever the case may be. Be aware that a gas regulator can definitely get a block in it. Now the way to check whether all of your gas valves are actually open and you've got sufficient gas is when you ignite the roaster, you'll see that the gas gauge lifts up whenever gas is flowing into the burner. So let's assume right now you'll see that the gas goes up ever so slightly, and then we know that there's actually pressure going to the burner. If there's no pressure going to the burner, it's obviously not going to lift up at all. So then you know that there's something wrong with the supply side and something's not opening up as it should, or my bottles are empty, or I have my switch over manifold to the wrong position, something like that. So resolving that issue will show you the gas gauge lifting up and flame ignition, as you can see. Now, the easy way to check whether you have got sufficient gas pressure is by connecting a gas valve or a gas flow meter to one of the test ports on the gas valve. Right, so when you get to installing your gas system, your gas installer needs to provide you with enough pressure and enough flow through the setup of your regulators for the roaster to run. Now the way to test if you actually have enough pressure and flow is to connect a pressure tester to the bottom entry of your gas valve and hook it up to a pressure tester or a gas valve or something like that. So I have one connected here, which is a simple pipe connected to a gas gauge, the same as that goes into the roaster, and this measures the incoming line pressure. So now let me open up the gas gauge, and you can see in this case that the dial went right round, so actually we have a supply of about 3.5 kPa at the moment. So remember, this isn't zero, it actually went right round. Now, this is what happens in a lot of installations when the supply pipe is too small a diameter. You need to test it when the whole system has flow going. So you can see that as soon as the burner was lit, the flow rate dropped. And right here, this is now our actual supply pressure under flow, which is different from supply pressure when there's nothing going to the burners at all. Remember that we can get whatever pressure we want, even with a 1 millimeter diameter pipe, but that doesn't mean that we can get the required flow rate of gas to the burners. So in this case, you saw that the supply pressure went down as soon as the burner started lighting up. So now let's assume, or let's simulate a very small pipe diameter by closing off our gas bottle. So let's do that. and shut off our gas burner. So look there, it looks like we have more than enough gas pressure. So this has gone right round to about 3.5 kPa. So when your gas installer gets to site and says, yeah, I've got more than enough pressure, look, here's the test to show that we've got 3.5, 3.8, whatever it may be, kPa of pressure, you need to switch on the roaster and make sure that that actually has enough flow rate to maintain that pressure while the burners are lit. So in this case, we're going to see the burners trying to ramp up to 100% now in prime mode. But because I closed off my gas supply, that's dropping as soon as I switch on my gas burner. So be sure to check your gas pressure while it's under flow, in other words, while the burner is actually lit up and ignited. Okay, so that concludes basically the supply side of our roastery installation. But I will tell you that we have a lot of questions and a lot of issues creeping up with the supply side. Most of them are because a valve isn't open somewhere. So make sure that your valves are open before you start your roastery, and that gets done with startup lists or startup procedures that you can set up for yourself. Just a quick little list for yourself or your operator that they need to run through in the morning before they get started with roasting. Open up the bottle, open up the gas valve, check what your gas bottle level is, and then we can actually continue roasting for the rest of the day. So we're going to switch over now to Donovan in the studio, and he's going to answer some questions around site preparation for your roastery.
Thank you, Neil, for showing us how the gas chain works inside the roaster. It's very interesting to see how it all comes together. Now, on gas and installation and how this all works, it's very important for us as roasters to make sure that we are using the right people, a professional gas installer, as well as a certified electrician. Because when we want to hook up our roasters when they arrive, we want to make sure that everything is correct and in place, and having a certified technician do the installation is great. I'm very happy to tell you that Genio has a very good process when it comes to doing our installations and our pre-installation work. They all come out to you or do a video conference call with you to make sure that all your points where your roaster is going to be hooked up to are within spec, as they would lay out for you guys in this installation guide that they'll send you. And so when their roaster arrives, it's a quick, easy turnaround process. As roasters, we get excited when we get new pieces of equipment, well, at least I do, and the last thing I want to do is have to run around for 2 days trying to find the right connection paraphernalia for my roaster. So make sure that everything is in place when you have to install your roaster. Not only that, these are very important things to consider is your insurances. From your investment perspective, we spend a lot of money on our equipment, and we want to make sure that if anything does go wrong, that we have everything in place when it comes to our gas and electrical installations. So it's very important when it comes to insurances that we have all these things in place. So in my roastery, I make sure that the gas installation is up to code, the electrical installation is up to code, so that if anything does go wrong, then I know that I'm 100% covered. And this goes for if you move your roaster, to make sure that you have made the right changes for the installation going forward. Yeah, so thank you, Neil, once again for that. And let's go back to Neil in the test rig and see what he has for us next.
Right, welcome back to the test rig. So now we're going to cover the internal side of the roaster, and that starts either from here going forward or with the latest series from here going into the machine. So what we have is our gas valve and ignition system. The red and black box is your ignition system, and that's also where your reset button sits. And your gas valve has the nuts on it so that you can calibrate your gas. You have your gas gauge and your gas burner. Now, let's start off straight away with one of the biggest questions, and that's to get the flame lit. So if something were to happen with my supply side, let's say I forgot a valve closed. The igniter will try 5 times to ignite the gas, after which it'll give you a safety cutout, and you need to manually reset the gas ignition system. So what it'll do is try 5 times to ignite the gas, but at this stage you know already that something is wrong. So if I switch to prime here, it wouldn't, to standby here, it wouldn't go into the lockout mode, but you'll see in a second now, there's the light that switched on because the system recognized that it's not picking up a flame and therefore it went into lockout mode. So to get out of it, you need to press the reset button here if you see the light being on. Now remember, when you do call us and say that the light is off, but nothing's happening, the light will only go on if we ask the burner to actually be lit up. So if we're not asking for it in standby mode, the light is not going to be on. So you need to switch it into prime mode first to ask the roaster to actually ignite the burner in the first place, and then you'll see the red light going on, not if it's in standby mode. So simply pressing the reset button and making sure that I resolve the issue before I do so will then ignite the burners. So it needs to flush gas through the system first, and that's why it takes a couple of tries to lit up. So we've had a question in the past, why is the ignition sound so loud when the flame is not lit, and then as soon as the flame lights up, it's a much lower frequency again? So let's try that. So you can hear the sound very loudly, and then as soon as the burner actually switches on, immediately it's a much lower frequency and you don't hear it as well. And the reason is because of the density of the air. So cold air transmits sound far better than hot air because it's less dense. And that's why the frequency changes between a lit burner and an unlit burner. Now, how the ignition system actually picks up if there's a flame or not is, believe it or not, but flames conduct electricity. So there's a little bit of electricity flowing from your gas valve to the ignition system through the gas flame and into earth. So it makes electrical contact. So if the flame is not there, let's say I close this off, that electrical contact is broken and the system tries to re-establish the electrical contact by igniting the burner. Now the last thing to consider when it comes to ignition is the ignition wire. So that's this red wire over here that plugs into both the red and black ignition box and also into the electrode at the burner. So what could very well happen is that this wire could pull out, and what you'll get then is a very soft ignition sound, which you can possibly hear over there, but you won't see a spark anywhere, and then you almost always know that it's pulled out at the box. And what could also happen is it could pull out at the ignition electrode, or what could happen is if this wire is damaged, possibly from heat or maybe somebody accidentally cut through it, it could spark through to any metal components in the roaster. So you have to trace the entire wire if you're not getting a proper spark at the burner, and see if it's not maybe sparking through, and you'll see the spark, especially if it's quite dark inside the roaster, you'll see the spark onto the frame or onto a motor or something else. It won't damage it because everything is earthed, but you can quite easily see this spark over here when it's sparking onto steel or sparking onto the burner itself. So let's open it up, and then we can see a proper ignition over there. So one of the things that happens quite often with customers in South Africa specifically is that they have the orange pipes connecting between the supply side and the roaster. And those orange pipes have got quite a small diameter. They aren't really allowed overseas, so that's why it's a very South African problem to have. So the orange pipes constrict the gas to some extent, and that causes a jumping of the needle on the gas gauge. So I'm sure many of our customers have seen that before, where especially if you go down to lower pressures, the needle jumps all the time and it doesn't settle down. And that's because of that smaller diameter of the orange pipes. So try to install PEX piping like we have here, which is a beige color kind of piping, and your gas installers can definitely help you with that. And that will give you a bigger diameter and reduce the risk of the needle jumping on the gauge. So when we get to an oscillating gas regulator, you might hear that sound that's coming from it now. It's a high pitch frequency, and that's because the diaphragm in the gas regulator has started oscillating. Now, to change an oscillating frequency, you need to add weight to it. So let's just put the cap back on, and the oscillation will stop immediately. But with that oscillation comes the gas valve, the gas gauge actually jumping up and down. So we can start and stop this oscillation by just putting on the cap. So never ever throw away the cap of your gas regulator. So maintaining your roast chamber and the burner itself is very simple. Just take a nylon brush when the burner is really cold and give it a brush from time to time, and make sure that the stainless steel surrounding your burner is always as clean as it can be, because you can actually see the burner in the reflection of the stainless steel, so you won't need to crouch down if you want to see what the flame looks like. So keep it nice and clean, make sure that there's no combustible materials around it, so that there is no chance of fueling a fire in the event that you possibly have one. So make sure that your roaster is clean, and just give the burner a brush from time to time. And when you're done roasting for the day, make sure that you obviously switch your roaster into standby mode, and the roaster can actually stay there. You don't need to switch it off at the main power switch, because all of the electronics shut down at that point. But make sure that the burner switches off that the roaster switches off the burner, and close off your safety valve at the wall before you go home. This will help for if there's any gas leaks going into the building. And it is good practice to close off the main valve before your high pressure regulator, or possibly just after your high pressure regulator. And if you don't have one, just close your bottles before you go home. Right, so calibrating your gas is probably the question that we have the most. And it's because our customers are really excited when the roaster arrives and they've got their gas set up and everything's ready to go except for the calibration. So let me run you through an entire example. I've switched up everything in this entirely beautiful calibrated system of mine, so I've thrown everything back to uncalibrated. So the first thing we do is we set the roaster into roast mode at full gas. And we want to see what the maximum pressure is that we can get from this particular supply system. At the moment, it's sitting at 1.75. So the first thing I'll do is remove the cap from my gas regulator and just turn this adjustable screw in almost as far as it can go, rather too much than too little, because we know we can squeeze out around 3.8 kPas from this. So the second step would be to calibrate the minimum and maximum points of my gas valve. So the first step is always to calibrate the maximum, and then we go on to the minimum, because the minimum changes when we change the maximum. So you can do minimum first, but you'll have to redo it as soon as you start working on the maximum pressure. So all we do is we switch to roast mode in maximum pressure, so 100% gas, and take the big brass nut with a size 8 spanner and turn it clockwise until you reach your desired maximum pressure. Now remember that this is also dependent on your gas regulator. So if your gas regulator isn't supplying the correct pressure, which is about 3.2 to 3.8 kPas of pressure, and again you can measure that by measuring the inlet tap of your gas valve while the burner is actually on. Now we can get to our desired maximum pressure. So I can turn it anti-clockwise to go down or clockwise to go up. And there's nothing wrong with going higher than 2.5. We simply calibrate all of our roasters to 2.5, but if you get a little bit over or a little bit under, that's no problem really. It's just the setup of your particular machine. If you're too low, let's say below 2.4, you might not be able to do a full 6 kilo batch in your desired roast time, which might be 12 or 11 minutes. If you're a little bit over, there's no problem with it. So here I have almost 3 kPas of pressure. I would say that's a little bit too much, so we don't want to give you too much rope to hang yourself. Rather bring it down to 2.5, because at 3 kPa you might very well get scorching and tipping if you turn the burners up all the way. So let's bring it back down to 2.5 and calibrate this thing properly. So adjusting the minimum point on your gas valve, requires you to turn the top nut anti-clockwise to bring it down and clockwise to bring it up. So first set your roaster into roast mode and turn your gas onto 10%. So at that point the burner should be at its minimum flame, and we can simply turn this small nut down to our desired minimum pressure, which is, let's say, around 0.4 kPa. So at this point we've got a minimum pressure set and we've got our maximum pressure dialed in as well. So if I turn the gas all the way up, I should hit 2.5, which I set a few minutes ago, and we can turn it all the way down to 10 kPa. Anything below 10 kPa will switch off the burner. So don't go into switch off, just set it to its minimum point, and remember that your minimum point should never be so low that the flame can be killed by a small little gust of wind and it needs to reignite. So if that's the case, increase your minimum setting by turning the nut clockwise, and that'll bring up your minimum level to where the flame is actually stable.
It's very interesting, Neil. I have one question. I see on this setup here, you've got this component that I don't have on my roaster. Can you explain to me what it is and how it works?
Yeah, so that's our little secret weapon that I had installed on this particular test rig of ours. So this is an optional extra that we can upgrade most of our roasters from about 2017 onwards.
Okay.
It's a digital pressure sensor, and it helps with consistency. So I'm going to explain to you in detail how it works on the tablet. But basically, instead of opening the gas valve from 0 to 100% on your tablet when you make a gas adjustment, you'd set it to exactly the pressure that you want, and that's what you see on the screen, and the gas valve will make sure to maintain that pressure throughout the roast.
Ah, that's interesting. So I think out of the 6 questions we had, I think 4 of them are solved by this component.
Quite
Is
right,
that correct?
yes. So that deals with gas supply issues quite easily. Now, because we can update the software over the air, we are working on popping up a myriad of warnings and things to show you that there's not enough gas available or something like that. And it will also cancel out any fluctuations that you may have in your gas pressure. So if you have an overpressure or a slight deviation from the set point pressure that you usually have on your gas gauge, this will cancel it out and maintain a given pressure exactly, irrespective of the supply pressure, as long as there is sufficient supply pressure. So if your supply pressure drops below, let's say 2.2, but you actually want 2.2 on your gauge, then obviously you can't get that because it's below the supply pressure. But if your pressure goes up again because you switched to a new bottle, the system will automatically go back to, in this case, 2.2 kilopascals or 22 millibars, whatever you set the system to.
That's very interesting.
Yeah, it's a big help.
Yeah, great tool for us. As I said, it's 4 questions are solved by just having this mechanism installed.
Yeah. It's a great tool to have, especially for that consistency. You know, as the day goes on, sometimes in the morning the sun is shining directly on the bottles, and then in the afternoon or at night it would be in the shade and it gets a bit colder. So there's always a small fluctuation in gas pressure. But using this system, we can keep it exactly constant to where your set point was. And also we do away with the gas gauge altogether, because what you would have seen here is exactly what it displays on the screen. So where you would have seen 2.2 kPa there, you'd see it on the screen where your gas adjustments are on your ProRoast app. So it does away with the gauge, but gives you all of that control in your tablet.
That's amazing. And potentially a money saver.
Very much so, because every roast that's inconsistent, at the end of the day, dials back to your consistency and your brand. So it's a rather important thing to have. It's not necessary, but if you can upgrade your system to that, then it's a really nice option to have.
Awesome.
Right, so let me give you a couple of examples how the digital sensor works. That's our adaptive gas system. So let's switch on the gas and bring it up to the maximum pressure. So remember that we have a slow opening valve, which reduces that woof effect that you can possibly get in a burner. So it'll always start slow and then gradually open up the valve if you ask it for full gas pressure straight from the get-go. So it'll never give you full gas pressure because that could be quite dangerous. Yeah. So it slowly ramps up the pressure. Now that we're on 25 millibars, as you can see on the screen, I'm going to turn it down a little bit. Let's say to 17 millibars. And on the gas gauge, you'll see that the pressure starts reducing. Now, we have a very aggressive system here, specifically so that we can showcase the PIT controller working and trying to find the set point. But you'll see that right now it stabilizes on 17 millibars or 1.7 kilopascals on the gauge. On the screen it's in millibar, but you can set that according to your preferences. So the point is that this system will maintain that pressure, and you can see the gauge going slightly up and down as the gas valve, as the gas sensor is picking up the pressure and trying to adjust and trying to maintain that. But as I say, in a commercial version, in a roaster, that'll be fine-tuned so that it finds the set point exactly and stays there. This is just for demonstration purposes. So if I increase the pressure back up to 21, you're going to see that the needle starts searching for that 21 again, being a bit over-aggressive at the moment. But here's the kicker, and that is if I close my gas cylinder to simulate a bottle going empty. Now I'm almost completely closed on the gas cylinder, but my pressure remains. So let me close it off. Now this is getting tight, so it is really almost closed now. And there you can see, now it's below. Now the supply pressure is at 0.8 kPa on the gauge. If I open that up again, and let's say I immediately give it full gas by opening up the bottle, you'll see that the pressure ramps up. But now the sensor is going to pick up that it's too high and start dialing it back down to 21 millibars or 2.1 kPa. So you'll see that in a second as the sensor picks up the pressure. Come on. And you'll also see that in the gas flame, of course. So there we are, sensor starting to pick up that we've got full pressure again and starting to reduce it. Now, as I say, that the commercial versions in the roasters will be fine-tuned for that specific roaster. So it'll be as fast as responding as possible and bring it back to the set point. But in this system, I wanted to show you that it's actually actively searching for the correct pressure. So as we play around with the pressure, let's bring it down to, let's say, 15 millibars or 1.5 kPa. You'll see that the gauge slowly goes down until it reaches that point, irrespective of my supply pressure. And this is very important. For example, if we're switching over to a different gas bottle, even that little dip will be completely negated with this system because it automatically adjusts the gas valve on your behalf in order to maintain the set point gas pressure that I wanted the system to maintain. So it really gives you that exact consistency when it comes to roasting, which is quite a valuable thing to have.
Yeah, very valuable.
Yeah, let's go back to the studio and have a couple of questions there. Okay, so welcome back to the studio. I think that was a nice exercise to have gone through.
Absolutely. See
everything laid out in front of you. And now we get to the part where you as a consultant come in.
Yes.
So, you know, we as manufacturers, we focus on the technical aspect from a machinery's perspective. When it comes to getting the best out of the roaster, that's where we sort of take a step aside, because we see ourselves as the engineering team of a Formula One race team. So the engineers are not really responsible for how to get the car around the track the fastest. We get feedback from the driver and set the car up and set the roaster up in the way that they want. But driving the actual car, that's up to the roasters themselves. And that's where people like you come in to give us a helping hand. So you and I meet each other quite often when it comes to field work, yes, where a customer gets stuck on a specific point and I pick up the phone and I say, Donovan, this is where you take the reins.
Yeah.
So give us a little rundown of how you got into the industry. I mean, you've consulted in the UK, in the UK and America and the UAE, and also obviously in South Africa. How did you get into coffee consulting?
Yeah, it's a very interesting question, and it's, if I could answer it plainly, I'm not quite sure, and I can tell you that it was a series of phone calls with someone having some issues, and then the invitation was extended, and from there it's just become a part of what I do, Neil. So yeah, and then we've had obviously conversations in the past when it comes to certain aspects of roasters having issues and discussing how to best resolve them, and coming to the conclusion that the relationship between manufacturer, yourself, and myself can become very important. And so where you leave off, I'll pick up and try and help the customer to better understand all the processes that go into actually roasting the coffee itself.
And you know, I think a lot of people are quite hesitant to make contact with a consultant like yourself.
Yes.
Because they firstly believe it's going to cost an arm and a leg.
Absolutely.
And secondly, maybe there's a bit of pride that comes into play with not wanting to bring in outside help. But I think you guys have a specific perspective on how to get the best out of a machine that's a bit more objective than subjective.
Yes.
Is you look at flow, for example, in a coffee roastery, and see how you can get more turnover, more production out of the shop. And I'm sure that you have that often when customers start growing suddenly, and they take on a big contract. How would you approach a customer now suddenly having to take on a 1-ton contract? Let's say they were on 250 kilograms on their 6-kilo roaster, and now suddenly they're looking at taking on a 1-ton contract. How would you approach that?
So firstly, I'd go into the roastery and see what the setup is and how they're operating at present. And I know from my experience, a lot of guys aren't thinking about these kind of contracts, and they do come along as they become more proficient at what they do as roasters. And what you find is that the original setup doesn't facilitate being able to handle the flow that's coming in. And so I would go in and look at every aspect of the organization, saying from when the green beans arrive to when they leave the roaster into the packaging area, and then to dispatch. You know, sometimes those systems clash with each other, and especially if you're doing a big jump from like a 200 kilogram to a ton, there's a lot of other things that the customer doesn't consider, like redundancy. What happens if my roaster goes down? What's my option there? And that's where we talk about maybe it's time to now look at a upgrade to a roaster, or just better organizing the flow of your roaster.
For example, packaging. We always find guys with their old foot sealers in their shop. It takes forever, and it's a silly thing to have. So a little conveyor sealer really doesn't cost that much money, but it increases your packaging efficiency by so much. So there can be a host of small things that you can do in your shop before you actually have to consider getting a bigger roaster.
Yeah, and a great example of that is one of my customers. When I arrived, they had a system set up, and I realized that their batch-to-batch protocol wasn't optimal, and that we increased their batch size, their turnaround time from roast to have 2 to 3 roasts an hour to have 4 roasts an hour. We changed the packaging area around, and in total we figured out that we saved them 5 hours a week.
Yeah,
and
that
is a lot. That is, like, if it's a 6 kilogram roaster, that's 20 kilograms an hour. Yeah. And
I'm sure that quality control is also probably the biggest part of your business. Is churning out lots of coffee isn't really that difficult, but doing it consistently and doing it to the specification that your customer wants, that comes down to cupping and sensory.
Cupping, sensory, having a color meter, having a moisture and density equipment. And again, I say these things and also take into consideration that it depends on the size of the organization. I know as more artisan type roasters, where our volumes aren't that much, to invest in that kind of equipment is very expensive. And so that's where we will then default to having a really good understanding of the sensory aspect of coffee, so that we can continually cup our coffees after roast to create that consistency that we need. And
the kind of questions that we often get is people wanting more sensors, specific kind of sensors, more of this, more of that built into the machine. And from a manufacturer's perspective, that's no problem. We can install as many sensors as you possibly want. But throwing data at a customer doesn't increase their quality. No. At the end of the day, knowing how to use the equipment that they have the heat output that it gives, the heat transfer, the batch size, everything like that, using that optimally and pulling everything back to the cupping table. Yep. I think that's probably the most important thing. I think the holy grail in coffee roasting is being able to draw a line from the cupping table back to the profile.
Yes.
And that's probably the most difficult bit.
It is, and I find one of the things where roasters lack the most, you know, and so doing that with the roaster is very important, doing a sensory development. But this is where I also like to talk about the SCA and what they've put together from a course perspective. They've got their foundations, intermediate and professional levels, and this gives a really good overview of understanding how your coffee roaster works, one, and then the chemical processes that the coffee goes through within the roaster. And so you're talking about extra sensors and extra that. It's all good and well having all these things in place. I mean, I love them, and I've asked you many times for certain things. And it is not because I want them just to try and help me, because it's retrospectively. Because I understand how everything is working in the roaster, having an extra sensor or having an extra this is more meaningful to me when I know the whole story about how the coffee is roasted from start to finish.
But I think getting to that point of being able to use that information retrospectively, that is where real, true dedication to quality and sensory development comes from.
Absolutely.
Okay, thank you. So now we're going over to a little clip that we have from Nicodemus Nabakwe from Seven Oaks Trading. So he's our head judge for the A Shot in the Dark competition this year, and was also last year. And he's going to give us a little insight into what the judges are looking for when they taste the coffee, specifically for the competition. But I think that will also be directly translatable to our daily practices in our roasteries. So let's hand it over to Nicodemus. Thank you very much for the clip, and see you soon.
How's it, guys? Nicodemus here from Seven Oaks Trading. I hope you're enjoying the second session of Tech Talk, all about gas, by Neil and Donovan. Now, these two guys are a big asset to the whole coffee community, and we are privileged to have them. Well, I'm here to talk about a shot in the dark judging and share a few tips on how to prepare for the competition. Now, this is my third year in a row as a judge, and I have to say that the standard of this competition has grown by far and wide in the country. The quality of roasts we cup keeps getting better and better. Now, as judges, we're a team of professionals who share the same passion in coffee like each one of you. And all we want is for roasters to bring out the best roast on the day. Everyone stands a chance to get through to the top 10 and carry the day as SA's best roaster. The first round of judging is cupping. Once we've selected the top 10 is when we have to go to the second round, which involves both cupping and blending, where we choose the best out of the best. Now, for a shot in the dark, we came up with a cupping sheet, which is almost similar to the SCA cupping sheet, but with a few changes. The first change we made was to double the score of flavor and introduce sweetness as a real score and not score as a perfect objective score of 2 points like on the SCA score sheet. But then we doubled the score. We want roasters to focus more on developing flavor and sweetness during roasting and to highlight these two elements in the cup. As we all know, we are cupping specialty coffee, and these two taste characteristics will be evident in the coffee. At the end of the scoring, this will give you a higher score if you impress the judges. Now, we also took out the other two perfect objective scores on SCA cupping sheet, which is uniformity and clean cup, as we expect the coffee to have both these qualities. Now, the second change we made was to introduce a score we call accuracy in description. We want, as a roaster, to tell us more about what you think coffee tastes like. Also a brief description on what went on during roasting of your coffee. If you're accurate on flavor descriptors, you get a higher score from the judges, of course. The other test characteristics remain the same, and I'm talking about aroma, aftertaste, acidity, and body. So many of you will ask the question, what is the perfect cupping roast? Well, our preferred roast for a shot in the dark is one that brings out the best of what the coffee has to offer. This coffee must score higher not only in intensity, but also in quality of all test characteristics on the cupping sheet. Please take a look at the SCA cupping sheet for your reference. So I have a few tips on what we are looking for. First, go for a roast that you think will highlight flavor, sweetness, and all other taste characteristics, hence bringing balance in the cup. Number 2, cup the different roasts and choose one that you feel stands out and that gives us accurate flavor descriptors of your coffee. You can also refer to the SCA cupping protocols for more information on scoring and test characteristics. Number 3, make sure you courier your coffee at least a week prior to judging. Okay, so when we receive your coffee, what we do is we need to check the color of your roast. And we would take a sample. Of course, grind, and then do a color check. Now, the reason why we do a color check is when we're calibrating the scores, and let's say we just want to be on the same page as judges, we always ask for what, let's say, the roast color was. And this helps us in our final decision making. And I think it's a fair playing ground to every other competitor in the competition. And then once we've done that exercise, we go ahead and do the cupping as per the SCA cupping protocol. And yeah, that's just basically what you go through. I hope you guys will give us the best roast this year, and may the best roaster win.
Okay, thank you very much to Nicodemus for that beautiful inset. And now we get to our lucky draw. So this is again for the people that sent in questions through Facebook. Thank you very much for them. And our 3 winners are each going to get a beautiful Coffee Mind set here. We've got the Roasting Foundation book, the Sensory Foundation, and Sensory Intermediate books from Morten Munchen. And also the coffee palette. Donovan, just tell us how one would use that in a roastery.
So the coffee palette is, what you do is you take your roast that you want to match, you take the beans out, you stick them in the middle, and then on your consecutive roast you would take out your triad and then match. And as you look, you can drop them out individually and drop until you see that you're getting closer and closer to the color. And then when you get closer to the color and you can see they match, you then at that point end the roast.
Yeah, and it's a really nice little tool. So let's get to it. Donovan, won't you pick us a couple of those entries in there, please?
Let's see who the lucky winners are. Oh, if you go lose one ball, put them back. Who's going to do the honors, Neil?
You.
Should I do it? Okay, let's do it. This one goes to We Roast Coffee Roastery in Port Elizabeth in South Africa.
There we are, your hometown. Congratulations to We Roast Coffee.
There you go, free courier service. I'll take it with me.
Hey, that's a good idea. Okay, next one.
Next one. Let's do the next one. Let's see. This is Paul Michael Gonzalez from San Antonio in the Philippines.
Hey, thank you very much for that entry.
All the way from the Philippines.
We'll get it sent off.
We've got 2 more to go. 3 more to go. 6
One more to go.
One
It's
more.
3
Oh,
prizes.
one. Yes, right. 3 prizes. Let's see who the lucky winner is. This is all the way from Potchefstroom, Etienne from Toro Coffee in South Africa.
There we are.
Well done,
Congrats,
guys.
Etienne. Okay, thank you very much, and congratulations to our winners. We'll get your packages sent off right away.
Awesome.
And that brings us to the end of our Tech Talk Session 2. Donovan, thank you very much for joining us.
It's been a
And
pleasure.
thank you for our tech team who put together the gas system so we can play on it and show you what goes on in the gas systems. And please leave a like and subscribe and make some comments on the video so that we can interact with you and see where the other questions are that leads out of this video. And stay tuned for session number 3, which will be out shortly. And thank you very much for joining us. Thanks, Donovan.
Thank you so much for having me.
Cheers. Brand ik mijn haren. Oh, brand ik mijn haren. It's sparking. All right? Hey, yo.